Here's your pre-calc lecture. It's 11.1.2, part 2. We're going to do 11-15, but we're just going to go really quickly through it. It says, what happens to the graph of a polar equation if it only has one variable? For each part below, make a table with at least 4 different r, theta pairs so that you can graph the equation. Then plot the points on polar graph paper and decide what the entire curve looks like. So this is a little different than what you were doing earlier when, remember, this was 3 times cosine of theta. Remember, it gives you a sideways circle that's on the x-axis. Cosine gives you a circle that's on the x-axis, and sine gives you a circle that's on the y-axis, but this one's flipped because the -2. But these ones, this is just saying the angle is pi over 4. So I can plug in any radius, because remember it goes r, theta. I can plug in any radius, and the angle is pi over 4. So on my polar graph paper, here's my angle is pi over 4. And even if I put in a negative radius, like if I put in a -2, pi over 4, I'm always going to get a point that's along this line, pi over 4. So theta equals pi over 4 is just going to look like a line going right on top of the pi over 4 grid lines. Okay, that's what pi over 4 looks like. Theta equals 2 pi over 3. Well, that would look exactly like any point on this line, because I can plug in a positive r or a negative r. I can say r equals 1, r equals 2, r equals 3, r equals -1, -2, -3. I'm just going to get a straight line that's on this angle grid line. Okay, that's those two. And then what if I just say r equals 3, and we don't, remember it's r, theta. So I can plug anything in for theta. I could plug in, I don't know, pi over 2, or pi over 3, or pi over 4. So if it's just r equals 3, then if I count these grid lines as 1, 2, 3, my radius is 3. I could say 3, pi over 2. As long as my r is 3, I can use any angle measure. So it's basically going to be a circle, like that. So that would be r equals 3. If I wanted r equals 1, I'd have this circle. Okay, so r equals -2. Now that's an interesting one. So I can pick any angle I want, because it just says r equals -2. So let's pick pi over 3. Well, there's 2, so -2 would be over here. And then, let's pick pi over 2. Well, -2 would be down here. Well, let's pick anything I pick. I can just go backwards by 2, and I'm still going to end up with a circle of radius 2. Okay, so r equals -2 would look like that. R equals -3 would just be a radius of 3. Hope that makes sense. I'm going to skip over to the fun stuff. I'm actually going to skip you down. So if you have a TI-83 that you like, then you can Google how to get it into Polar, how to switch it over. But I'm just going to use Desmos. So I've got the plain old Desmos. I don't want to, some of these I don't want you to see them yet. I'll reveal them one at a time. Oops. Okay, so in Desmos, you can just go to your plain old Desmos that you have already on the app on your phone. But when you want to start graphing something in Polar, then you don't put y equals. All you have to do is put r equals. And so how did I do that? Oh, well, you know, I'm not that great at this. I get the letters here, right here. I get the letters and I just type R, and then I find the equal sign. Find the equal sign. Where's my equal sign? Oh, I have to go to the 1, 2, 3s. You can do this on a computer too, and then I go equal, and then I can say what I want, like I don't know. Let's go sine of 5 theta. No, let's go sine of 6 theta. Let's see, functions. Where's my sine button? Sine. And then I'm going to go 6, and then you have to use theta. So basically you have to have r's and thetas. I can't use x or else it won't know that I want polar. It knows that I want polar when I use, see there's a little theta right there underneath the P. Oh, look at that thing. So that one is sine of 6 theta. And notice I got I got 12 little petals. And why am I messing around with this? Well, because it's fun, right? But what if I did 7 theta? 7 theta. So that's very interesting. So if you do an even number, I should wait and talk about this later, but if you do an even number, then you get that, I don't know, twice whatever that number's petals are. But if you do an odd number here, like 7 theta would be 7 petals. And if I go, well, I have some other ones to show you, so I'm not going to, we'll talk about that in a second. But anyway, cosine, I see that I got cosine theta in polar form simply by, instead of using a y, I used the letter r, and instead of using x, I used theta. Okay, so that's how you can do polar on your Desmos. So remember, cosine always is going to be on the x-axis, and sine is going to be, so that one was cosine. Sine's going to be on the y-axis, and I'm in polar form simply because I pushed r instead of y and theta instead of x. But then your book tells you to graph r equals 2 theta. So I just typed in r equals 2 theta. And look what I got. Oh, you can't see it. Whoa, I got a spiral. So that's fun. I'm thinking of a few of you in particular who are going to really enjoy this. You can try to ask yourself, why is that? Why is that? Like if you plugged some ordered pairs in and did it by hand, you'd keep going 2 times the angle measure. So think about that. And why does it make a spiral? I'm going to get rid of that. And your book also said, now graph r equals 3 times sine of 2 theta. So let's look at 3 times sine of 2 theta. Oops. I think what I did is I messed it up a little bit when I was zooming. But that'll give you a 4-petaled flower. So notice that you had an even number, sine of 2 theta, but you got a 4-petaled flower on there. Okay, so, and then let's look at 7 when I do 7 theta, I got a 7-petaled flower. But if I do 8 theta, I get a 16-petaled flower. And then, so I don't know, they just have you doing a little prediction. So that's just some fun stuff for you. I don't think we're going to go really deeply into all of that, but just enjoy your polar, knowing that you can graph things in polar and that it is beautiful. And just work through these homework problems. I think we've covered enough where you're going to be able to do them. And then next time we'll talk more about some of the different families of polar functions.